We're going to start learning how to write and balance the chemical equations by using these examples here. And we'll do more in class and we'll practice. So first, when we're going to write a word chemical equation, we would first start with writing the elements that are going to be our reactants. So we have solid calcium. So I'll write calcium reacts with solid sulfur. So then I'll write sulfur. And then it produces, and that's where your arrow would go, calcium, solid calcium sulfide. So then you would write calcium sulfide. So we have solid calcium. We could put that in parentheses with an S, and they're all solid, so we'd use the state of matter symbol behind them all. Now, when we're going to write the chemical equation, we're going to, using the symbols, we would use the symbols for calcium, which would be Ca, and then its solid state, so we'd put that in parentheses behind calcium, and then sulfur symbol is S from the periodic table, and the symbol for the solid state would be S. And now, to make calcium sulfide, we're going to use our ion chart, and we would find that calcium has a positive 2 charge, and sulfur has a negative 2 charge. So in that case, we need 1 calcium with every 1 sulfur when we make calcium sulfide. The last part, that's a solid state as well, the last part is to balance it. Now we're going to look to see if it's balanced already. We have 1 calcium atom over here, 1 sulfur atom. On the product side, we have 1 calcium and 1 sulfur. So this is balanced. You have to do no more. So now let's do the second example, letter B. Oop, I have to erase here. For our next example, letter B, we are going to take hydrogen gas, and it reacts with fluorine gas to produce hydrogen fluoride gas. Now in this case, we have to remember our diatomic molecules. Hydrogen is a diatomic, fluorine is a diatomic, so when they're alone, they will be written with a partner. So let's start with hydrogen gas. We'll write hydrogen is going to react with fluorine, and it yields hydrogen fluoride gas. So we're just writing the words out now. Hydrogen fluoride. Now, when we're going to do this with the symbols, we have to remember that hydrogen is always diatomic, so it'll be an H2. The symbol for its state of matter would be a G. It's in the gaseous state. Fluorine will be F2. It is also diatomic, and we would write a G, and then we'd have our yield sign. And now hydrogen fluoride gas, we'd have to look at our ion chart. We'd find that hydrogen is a +1, fluorine is a -1, and so we need 1 of each to go together, and so our formula for hydrogen fluoride gas is HF. Symbol would be a G behind it. Now our balancing is where we get using the coefficients. Coefficients are those numbers that we put out in front of the formulas. In this case, we will need to balance because we have 2 hydrogen molecules over here, 2 fluorine over here on the reactant side, but we only have 1 hydrogen and 1 fluorine over here on the product side. So our coefficients are going to go in front. We only put numbers where we need them, and you never put a 1 in front of the formulas. So what do we need? We have 2 hydrogen over here, but we only have 1 hydrogen over here. We have 2 fluorine over here, but we only have 1 over here. I can put a 2 in front of this whole compound, and that 2 stands for everything behind it. This is 2 hydrogen, and it's also 2 fluorine. So 2 hydrogen, 2 fluorine, 2 hydrogen, 2 fluorine. That would be balanced. Let's go on to the next example. Solid aluminum metal reacts with aqueous zinc chloride to produce solid zinc metal and aqueous aluminum chloride. So the word equation is going to be aluminum, excuse me, my writing is messy, reacts with aqueous zinc chloride. So then we'd write zinc chloride, and we'll put the symbols in the symbol equation, to produce solid zinc metal and aqueous aluminum chloride. So now we're going to have two products here. Solid zinc metal, so zinc, zinc, and aqueous aluminum chloride. And so we'd write out aluminum chloride. Aluminum chloride. Now, when we do the symbols, we'll write in the solid, liquids, or solid states, or the states of matter. So if I erase this now, this is the word equation. Let's erase this, and we're going to do the symbols now. If we have solid aluminum metal is just the aluminum. That is what we have, just the element aluminum, and it's the solid state, so we have an S. It's going to react with zinc chloride. The zinc chloride here, now we have to make that formula and make it properly. Zinc from our periodic or ion chart is +2. Chlorine from our ion chart is -1. Okay, so we're going to need 2 chlorine for every 1 zinc. So this compound would look like this, ZnCl2, and it's aqueous, so we'll put in parentheses AQ, and now it's going to produce, so the arrow goes where the produce sign is, and it's going to make solid zinc metal, which is just zinc, Zn, and that's a solid, so I'll put an S really small behind there, and aqueous aluminum chloride. So aluminum chloride here. Aluminum is a +3 from our chart, and chlorine is a -1 from our chart. So you're going to need 3 chlorine for every 1 aluminum. That's from last chapter. So AlCl3, and it is also aqueous, so I'm going to squeeze in an AQ here. It's kind of messy, but you would have an AQ right up in there beside that. So here is our chemical reaction with the proper formulas and the proper symbols for their states of matter. From here, we need to assess whether it's balanced or not. So to see if it's balanced or not, we are going to count up the atoms on both sides and see how many we have. On the reactant side, so here's my reactants, here's my products, I have 1 aluminum. I have 1 zinc. I have 2 chlorine. So here's my 2 chlorine, 1 zinc, 1 aluminum. On the product side, I have 1, that got messy there. So I have 1 zinc, I have 1 aluminum, and I have 3 chlorine. So these are the products over here, these are the reactants. So if we look at this, I have 1 zinc, 1 zinc, 1 aluminum, 1 aluminum. What can we put in front? So I'm going to erase these, underline, whoopsie, I got the wrong one. Underline these where we're going to put our coefficients are going to be right out in front, and I don't want that big erase, that big thing. Okay, so we just want the numbers that are out in front. Let us figure out what numbers. So if we have 1 aluminum over here and 1 over here, our problem seems to be our chlorine, right? We have 2 over here and 3 over here. So we're going to find that least common multiple, which would be 6. So we are going to add numbers as coefficients out in front of the formulas. So we have 2 chlorine. We would want it to get to 6, so I'm going to put a 3 out in front. That will make 6 chlorine, but it also makes this 3 zinc, right? 3 zinc, and then 3 Cl2s, which would be 6 chlorine. So let's erase those arrows there. On this side, can we fix the zinc by putting a coefficient out in front of it? So now I have 3 zinc, and my chlorine isn't fixed yet though. I need to get that to 6. So a 2 here will make 2 aluminum, but it will make that 6 chlorine. So now my chlorine is 6, so that's check. That one's done. I have 3 zinc, that's done, but now over here I have 2 aluminum, and I only have 1 aluminum. But I could put a 2 in front of aluminum over here and make that 2. So double checking. I have 2 aluminum, 2 aluminum. I have 3 zinc, 3 zinc. I have 6 chlorine, 2 times 3, 6 chlorine. This is a balanced chemical equation. This is how you do these. I'm hoping that you're getting this. We're just doing these examples together, and then we'll do more practice tomorrow in class. The number 2 question here, translate the following chemical equations into sentences. What you need to do is find CS2, and you need to determine what this compound is. So we're going to name this formula. So C is carbon, and S from the periodic table is sulfur. And when it's in the second position, it ends in "ide." So we have carbon sulfide, and we could have said carbon disulfide if we use prefixes, correct? So carbon disulfide reacts with O2 is just oxygen, reacts with oxygen to form CO2, which is carbon dioxide, and sulfur dioxide. And then you would add the gas and liquid in those words. So you'd say carbon disulfide in the liquid phase reacts with oxygen in the gaseous phase to produce carbon dioxide in the gaseous phase and sulfur dioxide in the gaseous phase. So the same thing could be done for the next example. The next example is sodium and chlorine there, which if you put those together, you're going to make sodium chloride. Reacts with, and then Ag, you would look up what Ag is and what NO3 is. And if you look on your charts, Ag is silver, NO3 is nitrate. So you're going to have sodium chloride reacting with silver nitrate in aqueous solutions to produce sodium nitrate in the aqueous solution and silver chloride in the solid state. So there is your chemical reaction that is going to be in the words. Number 3, hydrazine, which is N2H4, is used as rocket fuel. Hydrazine reacts violently with oxygen to produce gaseous nitrogen and oxygen. Write the balanced chemical equation. So we're not going to write the words out, we're going to write the equation. So we have hydrazine, and they give you the formula for hydrazine is N2H4, and I know that's hard to read, but it is N2H4. It's used as rocket fuel. It's going to react violently with oxygen, and so oxygen is diatomic, so when it's alone, it's always O2. And then it says to produce gaseous nitrogen. Nitrogen is also diatomic, so I'm going to make it N2, and it's gaseous. They gave us that. And water. Water is H2O. Here is our formula, and now we just need to make sure it's balanced. The first thing I do is on the reactant side, I'm going to list everything that I have. I have 2 nitrogen over here, 4 hydrogen, and 2 oxygen. On the product side, I have 2 nitrogen, 2 hydrogen, and 1 oxygen. From here, we need to figure out where our coefficients, or what coefficients we need. Coefficients are going to be those numbers that go in front of the formula. We are not going to change our formula from here. Never change your subscripts. We only put coefficients out in front. So if I have 2 nitrogen and 2 nitrogen, well, that's balanced, but my hydrogen isn't. I have 4 and 2. So if I think about this, we might have to erase, so always use pencil. I need to get this one to 4. I could put a 2 in front of hydrogen here, and let's see what that does. So now this will be 4, but now this 2 is also for that oxygen, so now I have 2 oxygen. Now, I have 4 hydrogen and 2 oxygen and 2 nitrogen. 2 nitrogen, check, 2 nitrogen, check. 4 hydrogen, 4 hydrogen. 2 oxygen, 2 oxygen. So the only number I needed was in front of the water. And so I don't need these lines. And you don't need to put those lines in. I just put them in so you know that you're putting numbers in front of the formulas. So now this is balanced. For the problems on page 258, we're going to do these examples now. So the first one, write word, formula, and balanced chemical equations for each of the following reactions. Solid magnesium and aqueous hydrochloric acid react to produce aqueous magnesium chloride and hydrogen gas. Sorry that it isn't very clear. But so we have solid magnesium and aqueous hydrochloric acid. Here is where you need to memorize the formulas for acids. So refer back to chapter 7 and get those acids memorized, and we'll be able to use those now. So solid magnesium, we're going to skip right to the formula equation, okay? Magnesium has a formula of Mg, and it's solid, so we'll put S in parentheses. Aqueous hydrochloric acid, now going back and looking, hydrochloric acid is HCl, and it's aqueous, so we'll put AQ behind it. Then to produce, this is where we'd put our arrow, aqueous magnesium chloride. So we're going to have magnesium and chlorine put together. So we're going to look at our ion chart. Magnesium is a +2, chlorine is a -1. So you'll need 2 chlorines for every 1 magnesium. And so our formula would be MgCl2, and it's aqueous. So I'm going to go AQ here. And I'm going to erase this down here. And the last part is water. And water is just H2O. So you're going to put water at the end there. And I didn't have enough space, so H2O at the end there. So from here, this is where we need to do our balancing. Once you make all the formulas, you do not change any subscripts. You only change the numbers out in front. So we have on the products, on the reactant side, we have 1 magnesium, that's a 1, and we have 1 hydrogen and 1 chlorine. Over here on the reactant side, I have 1 magnesium, 2 chlorine, 2, oh wait, did I mess up? Oh, I went to the second one here. We're going to make hydrogen gas. That's my error. We have to go back. So back to this one. I rewrote it here. Magnesium plus hydrochloric acid makes magnesium chloride and hydrogen gas. And we would put the S and the aqueous, the AQ and the AQ, and the G behind the hydrogen. I'm going to leave those out because let's practice balancing here. So if we look here, we have magnesium on this side. We have 1 magnesium over here. We have 1 hydrogen and 1 chlorine. On this side, we have 1 magnesium, 2 chlorine, and 2 hydrogen. So our reactants and our products. From here, let us try to put coefficients in so that we can balance it. If I have 1 hydrogen over here and 2 over here, maybe I can put a 2 in front of HCl, which will change this to 2 hydrogen and 2 HCl, or 2 Cl. And so 1 magnesium, 2 hydrogen, 2 hydrogen, 2 chlorine, 2 chlorine. Check, 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 check. That is balanced. So we just needed that 1 coefficient. So let's do another one. Can I get it all the way done? If we have aqueous nitric acid So we have aqueous nitric acid. I'm going to leave the symbols of the state of matter out for now so we can practice making and balancing. Now, nitric acid is one of those acids, and that is HNO3, which you will memorize. It reacts with solid magnesium hydroxide, so it reacts with, so the plus sign. Magnesium is +2, hydroxide is OH, and it's -1, so we're going to need 2 of these with every 1 magnesium. So we need to put parentheses around that OH because that's a polyatomic, and you'll have 2 of it. And then we'll have our arrow. And from here we need to look what we have. It's going to produce aqueous magnesium nitrate and water. So nitrate is NO3 and magnesium is Mg. And so we have to look at what is nitrate. I believe it is -1 and this is +2. And so we're going to put those together and we're going to have Mg, and then we'll need 2 of the NO3s, and then we'll be making water. So I'm going to put water right here, H2O. Now this is a goofy one. It's what we call a double displacement. I'm going to have you write water in another way, just so you can see what's happening here. Water can also be written HOH. The OH came from here, and then that's an H. So it's basically the same. H2O is 2 hydrogen and 1 oxygen. It'll help us balance this to write water like that. And you can do that. So first, let's look at what we have on each side. I have 1 hydrogen here, but I have 2 hydrogen here. So I have a total of 3 hydrogen over here. I'm going to not look at those hydrogen individually, but I'm going to keep them separate. So I'm going to write them a little different. Okay, I just wanted to show you those first, and then we can, So from here we got to balance, and so we're going to have 1 hydrogen over here and 1 nitrate. So I'm going to keep these polyatomics together. 1 magnesium, and over here 2 hydroxides. On the product side, I have 1 magnesium, 2 nitrates, 2 hydrogens, and then 1 oxygen. But now I want to write that differently. Okay, I had trouble erasing, so I had to scratch it out. Okay, so I'm going to write this as HOH, like I had showed you before. So we're going to have 1 hydrogen over here, and then look at this one as a hydroxide, and then 1 OH over here. So that'll help us balance this a little bit better. We have 1 hydrogen, but we have 2 OHs and only 1 OH over here. So if I put a 2 in front of this OH, this HOH over here, which is water, we could put 2 in front of water. That changes this here to 2. I'm going to use pink. That will be 2. And then this one will also be 2. Now let's fix it on the reactant side. So I fixed my hydroxide, but now I screwed up my hydrogen. What if I would put a 2 in front of this hydrogen, in front of nitric acid here? That will make 2 hydrogen over here, but it also makes 2 nitrates. So now let's just assess what we have. I have 2 hydrogen, 2 hydrogen, 2 nitrates, 1 magnesium, 2 hydroxide, 2 hydroxide. And so I went back and forth, and I just picked one to start, and I put a coefficient in front, and then I see how it affects the rest of it, and then I try to fix the other side and see how it affects the rest of it. It's kind of a trial and error. Again, use pencil. I'm not going to accept scribbling out like I just did right here. I just couldn't figure out how to get it to erase without doing the whole thing. So anyway, let's do the second example now. Solid calcium metal reacts with water to form aqueous calcium hydroxide. So we have calcium metal, which is Ca, and it would be solid, so I'd put an S in there. Reacts with water which I'm going to make it HOH. That's just a trick that I've learned to look at water in that fashion till we get used to it. And then to form aqueous calcium hydroxide. Calcium is Ca, hydroxide is OH, +2 and -1. So I'm going to need calcium, and I'm going to need 2 hydroxide with every 1 calcium. And that was messy, but calcium is a +2, hydroxide's a -1 from your charts. And then the last thing it makes is hydrogen gas plus H2. And so we would have S in parentheses. The water is going to be a liquid. Calcium hydroxide is aqueous, so that would be AQ, and this would be a gas. So there's with our states of matter. Kind of messy looking, but now we need to balance. So the first thing we need to do is assess. I have 1 calcium over here, 1 hydrogen, 1 hydroxide. Over here I have 1 calcium, 2 hydroxides, and 2 hydrogens. So we have 2 and 2 over here, and we only have 1 of each over here. If I put a 2 in front of the HOH, that does change this to a 2, and this one to a 2, and then it's balanced. Double checking. 1 calcium, 1 calcium. 2 hydrogen, 2 hydrogen, 2 hydroxide, 2 hydroxide. So there is our balanced chemical equation. The examples on page 260 we will do in class as practice to see if we understand what we're doing. So this is the end of what you need to do for this lecture. Thank you and have a good night or good day.